this is like a number theory question, and it's definitely a pretty challenging problem. So in this question, we have positive integers x and y are the two smallest positive integers for which the product of 360 and x is a square, and the product of 360 and y is a cube. We want to know what is the sum of x and y. So to do this question, a lot of the times, especially with number theory problems, where you have stuff about cubes or like squares or like factors and things like that, a lot of the times what you would want to do is you want to prime factorize the numbers. So in this case, the number that we're given is 360, right? So it might be a good idea for us to write 360 in terms of its prime factorizations. So if we were to factor 360, we know that 360 is 2 times 180, and we know 180 is 2 times 90, and we know 90 is 2 times 45. We can keep factoring. 45 is 3 times 15, and 15 is 3 times 5. So that means the prime factorization of 360 is just going to be 2 to the third times 3 to the 2 times 5 to the 1. So that's going to be our prime factorization of 360. So let's just write it here one more time. 360 is 2 cubed times 3 squared times 5 to the 1. And then we're given, if we were to multiply 360 by x, they told us that the product of 360 and x is a perfect square, is going to be a square number. So we want x to be as small as possible. So let's look at each like prime power separately. So let's first take a look at like this like 2 to the power of 3. So right now, 2 to the power of 3 is clearly not a perfect square. 2 to the power of 3 is equal to 8. And one way to tell that this isn't a perfect square is that we see this exponent is a 3, and 3 is clearly odd. And any number to an odd power, like in this case, 2 to the odd power is not going to yield a perfect square. We want an even power, an even number in the exponent in order to make it a perfect square. So if we just multiplied, if we had x have a factor of 2 to the 1, then when we multiply these two, we have 2 cubed and 2 to the 1. So that would combine into 2 to the 4, which is a perfect square. Now let's look at the 3 squared term. We see that 3 squared is already a perfect square, so we don't have to do anything about that. We can also just write 3 to the 0 if you want. And let's look at like this last term here, like 5 to the 1. Again, 1 is going to be an odd number, but we want to make it an even number in order to have it be a perfect square. So if we just multiplied by 5 to the 1, then that would yield a perfect square, right? Because if we had 5 to the 1 times 5 to the 1, that would give 5 to the 2, which is a perfect square. So that means x, this is going to be the value of x. X is going to be 2 to the 1 times 3 to the 0 times 5 to the 1. So if you just calculate that, that's 2 times 1 times 5. So we found x is equal to 10. And to find y, we would just do like a very similar process, right? So we still have 360 is equal to 2 cubed times 3 squared times 5 to the 1. And if we were to multiply this by y, we're given from the problem that like then the number is going to be a perfect cube. So if we were to multiply 360 and y, we'd get a perfect cube. So again, we're just going to consider each prime power individually. So let's first look at 2 cubed. Notice that 2 cubed is already a perfect cube, right? Like 2 to the power of 3 is 8, or you don't even need to calculate it. 2 cubed is like obviously a power, obviously a perfect cube. So we don't need any factors of 2 in y. So I can just write like 2 to the 0. And then now we can look at like 3 squared. We notice that like 3 squared is almost a perfect cube, but not quite. But if we were to multiply y by 3 to the 1, this would make it a perfect cube, because 3 squared times 3 to the 1 is 3 to the 3, which is a perfect cube. And finally, we look at 5 to the 1. Clearly, 5 to the 1 is not a perfect cube, but if we multiply it by 5 squared, 5 to the 1 and 5 to the 2 combined gives 5 cubed, which is a perfect cube. So this is going to be the value of y. So if we were to calculate this out, we would have 1 times 3 times 25, which is equal to 75. So that's going to be our value for y. And the question wants us to find what is the value of x plus y. We want the sum of x and y. So we know x is equal to 10, and we know y is equal to 75. So the sum, x plus y, is just 10 plus 75, which is 85. And that would just be choice B, and we would be done.